Okay, and let me start to share my screen. Just a minute. Okay, so we start working. Okay, so today we have to talk about soil description, some properties that we describe in the field. And we describe some properties that we can measure with our senses, like we can hear, we can see, we can even taste some soil properties, and we describe them according to some measurements to better classify the soil and better understand the soil evolution and the soil genesis. Okay? We describe the morphology of the soil, these properties that can be measured, can be identified and described in the field, because this is quite important to us. This is important because this define or determine how we should take samples in the field. If I just need one sample or I need several samples according to the depth or according to the temperature or the color of the texture of the soil, okay? These properties that I can describe in the field, they are really important because they express genesis and soil potential and fragilities. So I can understand how soil was formed according to its morphology. And I can understand which use I can propose for one soil and which use I should avoid for one soil, one specific soil according to its morphology, okay? All these properties, they should be described in the field, and some of them I can describe in a lab using some equipments, but the majority of them are described in the field, okay? We start to talk about some descriptions specifically to soil. In the next classes, we'll discuss about some other information that we have to measure and describe, okay? In this figure, we can see several soil properties that are described to soil classification, and the texture and color are the main soil properties to be described. You can see almost 100% all of the ethical groups that classify soil, they use texture and color to describe soil in the field. And why they use that? Because it's very easy to describe texture and color in the field. It's very, very easy and very useful to us to describe because they influence the water, the water resistance, the penetration of roots, and several other properties. Okay. Color is described according to three properties. The hue, that's the proportion of red, yellow, blue, and green. So the hue is a proportion of spectrums. Like I can see here, I can see the blue, the red, and something between them. I can see the red and the yellow, and something between them. I can see the green and the yellow, and something between them. And I can see the green and the blue, and something between them. So the hue is a just proportion of spectrums: red, yellow, blue, and green. And we measure the hue according to numbers that varies from 0 to 10. And we use these letters to describe the hue. So a number that's 10R is just a color that's very, very red, and there's nothing of blue or yellow or green in this horizon, in the soil horizon. But I can use something like this, 5YR. That's a color that have a half of yellow and a half of red. So I have the same quantity of this spectrum and this spectrum. And this soil horizon, it's more yellow than this one. This is total red, and this is red plus yellow. But I can also see something like 10 yellow and red. So it's something that use a lot of color from yellow and nothing from red. So I use a lot of yellow and nothing from red. And I can see a soil that very, very yellow color. Okay, so this number and these letters, they represent the proportion of the spectrum. So I can understand if soil is red, it's yellow, it's blue, or green. In tropical areas, we found several soils that are red or yellow, and it's quite rare to identify blue and green soils, but we can find some of them close to rivers and mangrove areas, but it's not so common. Generally, they are red or yellow, okay? And this number can identify the proportion of red and yellow or blue and green, and they represent to us the hue of the soil horizon. Another property of color is the value. That's the illumination, the proportion of white and this spectrum. So how we can see there? We can see a lot of white and we can see none of white. And here is just your spectrum, like total red or total blue or total red or white. We don't see the proportion of white here. So we can mix white with this spectrum, red, yellow, blue, or green. So we can have a pale red or something like a not so strong red or not so strong yellow, okay? And we have the chroma, that's a saturation of color, like here. We can see a color that's very, very white, and we can have a strong color, a saturated color. We used to change the chroma in some pictures that we take, like Instagram. We can add some filter, and the filter, they change the saturation of the color. We can see several soils that have low saturation and high saturation, low value or high value. And they both change from 0 to 10. Okay, so we can have low value or low chroma and high value and high chroma. They express several properties of the soil. Here we can find some pages. Oh, I'm sorry, just someone's asking to enter. Just a minute, okay? Okay. So here we can find 2 pages from Munsell color chart. Munsell color chart is it's just one equipment, one book that we use to describe soil color, the color of some soil or some horizon, okay? We can find here several dishes with different colors, here, like here, and we need to compare this dish, this pillows color with the color of the horizon. So I put some soil in my hand and just compare the color of the soil in my hand with these colors. Oh, okay, I understand. I think that the color of soil is here. It's very close to here. So I just need to measure these properties. This color is on page 7.5, yellow red. So I have here the hue. So I know that I have a mix, I have a mix of yellow and red, but I have too much yellow compared to red. So the colors are more yellow than red here. Beyond the hue, I have the velo and the chroma here. The velo, as I said, varies from 0, that we can see here in this page, and 10, that we also can't see in this page, but we can see several velos, like 8, 7, 6, 5, 4, 3, and 2.5. We can see that velos are lines, like here, and we can compare this velo, 8, with this velo, 2.5. And this velo has a lot of white mixed with this spectrum, this hue, and here we have no much white mixed with this hue. So this color, it's 7.5, yellow red, 5, that's the hue, 5 is the velo, and here I can identify also the chroma, that's here. The chroma are the columns, the bars that I can understand here in a vertical direction. And here we can see the same velo and the same hue, but a saturation difference. Here, this color is hotter than here. So I can differentiate also the chroma. And this color is 7.5, yellow red, 5, bar, 8. 8, you can see here. So the soil description, the soil color, in this case, of this horizon that I identify here is 7.5, yellow red, 5/8, just this. If I identify another soil horizon, I should describe another soil color, and I take a new note, like, okay, I can identify a horizon here. The soil is here. So it's 7.5, yellow red, 7/7/3. So it's here. Okay. It is a universal code, so everyone in the earth can understand which color you describe in the field, okay? All these colors should be described for all horizons that you identify in the field, and you should describe them dry and moist. If the soil is dry, of course, if you go to field and the soil is moist, you just can describe the moist color, okay? But the official color of an horizon is the moist color, okay? Someone can say some words about color. Do you think that measure color in the field is important, and why? Someone can help me to describe why take a note about the soil color or horizon color is important? Someone? Oh, please.
For easy description. So
No, but why do you think that's important to describe soil color? Oh,
yeah, sorry.
David, please.
May I come in? Okay, thank you. In my opinion, I think soil color is mostly determined in the field because of its dependence with the light. Even though when we see those pedologists who undertake soil description, they mostly prepare the, how do I say, the soil that they are going to study just in the side of the sun, because the sunlight has the light has significant effect on the determination of the soil color.
Okay.
So,
And please finish.
Since the color of the soil is depending on the light, pedologists mostly use to determine the soil color in the field.
Okay, David. Let me ask you something. Do you think that soil that's a lot of hematite, they have the same color of a soil that there's no hematite? Do you think that it's...
If I get you, I think so. It depends on the condition of the soil. I mean the condition of the light that you are going to study the color. That's my opinion.
Okay. Okay.
Maybe.
Okay. Kenneth, please. David, thank you. Kenneth, please, you can open your microphone.
Hello?
No. Oh, okay, and let's return here. And people, color, it's quite important to describe in the field because it represents, it evidence a lot of soil properties, okay? Just think, if you have a horizon that has these colors, one of them, okay? And another horizon that has these colors, but both of these horizons are in the surface. Which one do you think that has more organic matter? This horizon, the horizon A, or not A, I'm sorry. Let me put a number so it can be easier, okay? So I can identify a horizon that has this color, and it's number 1, okay? And there's another horizon that I describe in the field, and it is this, and the number 2. Which one do you think that has more organic matter? Number 1 or number 2? Number 2. Yes. Yes, it's number 2. Why? Oh, Dimi, please talk. Please open your microphone. Yes, it's dark, but oh, yes, it's because the dark color, they represent the evidence or organic matter. So dark horizons or dark colors, they usually reflect our rich organic matter horizon. So color, it's quite important because they represent an information that we just can know in the lab. I can't measure in the field the soil organic content. So I can't know, okay, this horizon that it has a lot of organic matter, but the color helped me to, okay, I can understand that this horizon has a lot of organic matter. I don't know how much, it's just 5% or 6% or 20%, I don't know, but I know that it's a lot. Or I can see this horizon and I say, okay, I can't find a lot of organic matter here. The organic carbon here in this horizon is too low. So color, it's quite important because I can distinguish soil, the horizons, according to the soil organic matter. And this is quite important to soil classification and the land use. So it's quite important to describe soil color. And another information that's quite important to us is distinguish the minerals that we can find in soil. Like if I found something here in a soil that's 10R, 10 red, we have a lot of hematite. That's a iron oxide. And if I found a soil horizon that's like this, I don't have hematite, I have goethite. It's another mineral. So the color reflects the minerals that I can find in the soil. But I just can know, I just can identify the minerals in a lab. So if I describe the color, the soil color in the field, I can think, I can imagine which minerals I can find in that horizon, in that soil horizon, okay? And minerals are quite important because they represent the influence of soil formation factors. If I have hematite in a soil, so I have a lot of iron, or I have a high pH, or I have a dry climate, or all of these soil properties at the same time. If I have a soil with a lot of goethite, I have a wet climate, I don't have a soil with a lot of iron, I have a rainforest above this soil. So the color reflect the minerals, and the minerals, they reflect the soil genesis. So it's quite important to measure the soil color in the field. Always. It's a principle of soil classification. Describe the soil color in the field. And you can use the Munsell soil color chart. Okay? And always we should describe the dry and the wet, or I'm sorry, the dry and the moist soil color. Okay? The dry if soil is dry. If soil is moist, because rained yesterday, oh, I can't just dry my soil to measure this color. Just, okay, to measure the moist color. Okay, it's fine. I go home and I don't have any problem with that. But if soil is dry, so I just need to measure the dry color and the moist color. Okay. Can use several equipments to measure the soil color. We can use the Munsell color chart, but we can use some apps. This is just one app that we can find. Okay, it's just, I'm not sure if they work for iOS. I'm not sure. Okay, you should try, but I know that several apps that you can use to measure color using your cell phone, your smartphone. Okay, it's quite easy. It's not the best option that you have. We have several equipments, professional equipments that should be used to describe soil color in the field, but we can use some of these apps to measure color, like, okay, which is the soil color of my garden, so I can understand and I can measure like this this app like here, and I can change the color so we can see some green colors and some blue and some purple colors and some red colors here, and you can see some yellow colors. And I just can put this, and I have this code right here, 10 yellow red 6/6. So I have the hue, I have the value, and I have the chroma. I have all the information, and I can compare the soil, the color of the soil, and this color. Okay, it's not the best option, it's not professional, but it's accessible, so everyone can use this. Okay, it's not the best option that we have, but we can use this sometimes. And there are several important features about soil color that we have to describe. And one of the most important is the reduximorphic features. The reduximorphic features are color partners that describe, that varies in the soil according to the depletion or concentration of iron and or manganese. Iron and manganese are elements that can be present in a different notation. So I can find red set and oxidized iron, and they have different colors according to this material, like I have also different colors of this iron according to the mineral that I can find. Hematite, goethite, ferrihydrite, and several others minerals. They have different colors. If I have a soil that's influenced by water, like his temporary flooded, like 1 month or 2 or 6 months, it is flooded. We have reducing conditions, reducing influence of this material. So all iron that's present in minerals, they change to the red set condition. And if this flooding it's not it's not continuous, if I have some months that the soil is not so wet, if soil starts to be dry, so oxygen returns to inside the soil, inside within the voids, the pores, so iron come back to the ferric formation, the ferric valence, the ferric notation. So this change the color and produce some reduximorphic features like nodules or masses or concretions. Okay, and this occurs with iron and or manganese. We can have the depletion, you can lose iron, or you can concentrate iron. You can lost manganese, or you can concentrate manganese. And all of this process, they produce color partners. They produce change of color in the soil. And they evidence that this soil, they suffer flooding, or they suffered in the past effects of flooding, or something with water that doesn't help water to penetrate according to the depth in the soil. Okay? Here we can see a picture that's quite easy to identify what is a reducimorphic feature. Like this first horizon, we can see here, a horizon that's here, okay. And this horizon, we can see a dominant color, a dark color, and we don't see several chains of colors. Okay, I can see something like darker here, so I can change and I can put this is a horizon and this is another horizon. So I can identify this in color and this is another color, but all of them are darker. And I can see in great or huge difference of color inside this horizon. But this, look at this. These are the same horizon, and I see a lot of differences of colors. I can see some yellow, I can see something redder, and I can see something gray color. So I can see at least 3 different colors in the same horizon. These are the reducimorphic features, because this evidence that flooding of soil changes the soil color. Even if I don't see the water, just by seeing these color partners, I can identify that this soil, he suffer influence of soil flooding. Okay? Here I can see some pictures that represent concentration, like here. Can you see concentration of iron here and here? So I have a gray color. The matrix of soil is gray. The soil is gray, but I have some dots of reddish color, like here. Here I can see a lot of them. Here, something orange colors too. this is concentration of iron in the soil. So you can see a change of soil color from gray to red, okay? And here we can see another kind of thing change, a depletion of iron that change a orange color to a yellow color to a white color, like here, almost gray color. So this is a change of soil color, and this change is produced by water, and this change, so it's a rhodosomorphic feature, okay? Rhodosomorphic features, they can be concentrations, as we said, and the concentrations are described as masses, nodules, or concentrons. So masses, nodules, or concentrations, okay? These masses are non-cemented materials. In this picture, we can see the gray color of the matrix of the soil, and we have some yellow bodies and red bodies. But this material is not cemented. This material is very porous, it's very loosey. So I can easily change this material with a knife. I can put it out of the soil with a knife, something like that. So this is a mess, okay? These materials, these colors, are rhodosomorphic features that represent iron concentration in the soil, and because they are not cemented, they are masses, okay? And I can identify nodules or concentrons. The nodules and concentrons, they are different only by the internal shape. If I can identify layers like here, you can see layers here and here and here. So we'll have a concentron. And nodules, they don't have an internal partner. So I can see layers in nodules, but I can see layers here in concentrons. And I can see also redox depletions, the loss of iron, like this. I can see a red color of the soil and some gray lines, like here. These gray lines are lines that express depletion of iron, depletion, loss of iron by water logging. We can see some clay depletions, the loss of clay that also change the soil color, okay, like this. In the field, we can see a brief change of color between this horizon and this horizon, because here we are losing clay. You can see several coarse fragments here and here, like a lot of sand. And because we are losing clay, we are also losing color. And probably we have high velo and high chroma in here compared to this horizon. And we also, okay, this picture, it's a picture that we can see in a microscope. That's quite easy to understand how loss of clay can change the color. Like here, we can see very, very easy a change of color. This white region and this yellow region or red region or orange region. It's not a problem, okay? This region has a different color from here because we are losing clay here. So we have a depletion of clay, okay? And it also change the soil color. And we can have a reduced matrix like this. You can see a gray color, and you can see here a gray color too. So here we have a horizon, a dark horizon with a lot of organic matter. We have a B horizon, our yellow B horizon, and we have a gray C horizon, a reduced matrix, okay? Here we can see some reduximorph features also, concentration of iron again, but here we can see a gray color that evidence a loss of iron or a concentration of reduced iron. The reduximorph features, they should be described according to kind. So which kind of feature could we describe in the field? We can describe the reduced matrix like this. This is a reduced matrix. We can see the clay depletions like this picture. We can see this in the field or this in a microscope. We can determine the concentration of iron, and can be a ferrous iron, or can be a ferric iron, or you can have a mix of iron and manganese in the soil horizon. So here we have just ferrous iron, ferric horizon, and here we have a combination of the both iron and manganese. We also can have jarosite or only manganese concentration in a field in soil horizon, and we can identify this difference, okay? All of them can be cemented or non-cemented. So the masses are not cemented reduximorphic features. So I can identify some materials that very loosey, it's very easy to press this material because they are not cemented, okay? Let's see some of them. Okay, like here, this is a mass of jarosite. Can have a concentration of jarosite that this is yellow color, and this yellow color represent this material, this specific mineral, that's jarosite. Jarosite is very common in mangrove areas, in areas that you have a lot of sulfur and iron at the same time. It's not so easy to find these elements in a high concentration in the same soil. So generally, we can find jarosite mass in mangroves because we have the influence of sea water, and we can have the water from rivers. The seawater is rich in sulfur, so we have a lot of sulfates. And the rivers, there are a lot of iron in the water, so I have rich content, high content of sulfates and iron. They can be combined and create some sulfides or sulfites like pyrite and jarosite, okay? We can also find these concentrations, this ferric concentration of iron, okay? So we can see a gray color of the matrix and these reddish dots these red dots that represents a iron concentration, okay? And we can see cemented materials like this one. Cemented materials, they should be described as nodules or concretions. These nodules has no layers. You can't find any kind of partner inside these nodules, okay? And you can't see any crystal at 10 times of magnitude of amplification, okay? And they can see a ironstone, iron manganese, a jarosite, or a plintite material. So these materials are the nodules. And we can see some materials that has layers and are cemented. If the material are cemented and has distinct layers, you can find a partner inside partner in this material. These are concretion, and you can't see also crystals here. And we describe them as iron manganese, or we can describe them as surface coats that are films or hypocoats of manganese or iron above gravels or coarse particles, okay? So let's see some of them. Here is a concentration cemented of iron. It's a crystal of pyrite, okay? This is a nodule of iron. It's a cemented particle, a cemented body that we can find in the soil, but it doesn't have internal partner, okay? This is a plintite, so I can see this material cemented. It's not easy to break it. I can use a hammer to break it. I can't break this with my hands. It's quite hard because the hardness of these materials are very, very high. We have here a manganese concretion. In general, manganese concretions are very dark, okay? And they has an internal partner because it's a concretion, it's not a nodule. So I can see some layers here inside the material. And here I can see a surface that's coated by iron. So it's an iron surface coat. It's very, very common in semi-arid and arid areas, like a desert. I can see a lot of them in areas that are very, very dry. Also, I should describe the reducimorph features according to its quantity. So how much material I have in my soil horizon. If I have up to 2%, I have just a few reduximorphic features in my soil horizon. If I have 2 or 20, between 2 and 20% of material inside my soil horizon, so 2 or 5 or 10 or 50 or 18 or 20%, we have a common reduximorphic feature. And if I have more than 20%, I have many. So 25, 30, 35, 50, 60, 90% of my material of my soil horizon, it's covered by reduximorphic features. It's composed by reduximorphic features. So I have many. So 2% and 20% are key numbers to identify. If I have up to 2, just few. If I have between 2 and 20, it's common. And if I have more than 20, so I have many reduximorphic features in my soil horizon. It's quite important because if I have few reduximorphic features, indicates that the influence of water is not so high. So this soil horizon or this soil layer is not so influenced by water. But if I have common or many reduximorphic features, indicates that I have water that influence a lot this soil horizon or even the soil. So the water changes a lot. I have several months or years that this horizon or this soil is influenced by water, is red set, it's waterlogged, it's flooded area, and several other months or even years that this soil or this horizon, it's not flooded, it's not logged, okay? I should describe the size of these materials too. So I have to describe if the materials are fine, are medium, coarse, very coarse, and extremely coarse according to diameter of these materials. So I just have to compare my material with a rule. If I can measure how many millimeters this material has, so I can understand and classify the size of this material. It's quite important too, because fine materials represent areas that are not so influenced by water, and coarse, very coarse, and extremely coarse materials indicates that there is our area that we have a lot of concentration or depletion of iron and manganese. So the process in these areas that have a lot of gravels or bodies that very, very big, are huge in the size, so we can think, we should understand that intensity of the process of depletion or concentration, it's high. It's different from here, because here the intensity of this process, so we don't have so much iron concentrated or depleted, or we don't have so much manganese depleted or concentrated in that soil horizon, okay? So it's quite important to describe the size of the material. Here we can see a very coarse material, very, very big material. This is my hand. And here we can see a fine material, very, very small. And this represents different concentrations of iron. The concentration of iron here, it's very, very incipient. And here we have a lot of concentration of iron. We also should describe the contrast of the reduximorphic features comparing with the matrix. So we can identify a faint contrast, a distinct or a prominent contrast between the reduximorphic feature and the matrix. If color of the reduximorphic feature and the soil are quite similar, it's hard to distinguish them, or it's quite hard to find these materials here. You can believe we have a lot of plintite, of iron nodules here, but it's quite hard to identify just with a picture. I should use my hands to describe, okay, this is a hardest part, so it's an iron concretion here and here, so I have a faint contrast. Or I can have a distinct, that it's easy, I can easily identify the gray color and this yellow color, but it's not so easy. They have the same hue, or they have a light difference of color, they have a light difference of value and chroma, so we have a distinct contrast. And we can identify a very easy to see like this. It's a very dark red color and gray color, quite close to another one. So I can see that's a prominent distinct, a prominent contrast between the reduximorph colors, the gray colors, and this matrix, this reddish color of the soil. Okay, so it's quite easy to understand here. It's not so easy here, and it's not easy here. Someone ask something? Just a moment. Okay. Oh, please, Kenneth, open your microphone. If we can hear you. Can if you are trying. Oh, okay. I saw here if you can use the color to describe cations and anions. Sometimes it's not so easy to do that because some cations have the same color and some anions are the same color. If you compare goethite and jarosite, both are yellow. So it's not so easy to identify, okay, I have this soil that's very rich in sulfate, or they are poor in sulfate because it is yellow. We can't understand this, okay? Okay, Kenneth, you asked because of formation of such soil covers different horizons. Oh, okay. Why some horizons are very different? Okay, it has different colors because some horizons are influenced by different soil formation factors. Okay, let me explain this. Okay, let me show you just here. Okay, we can think in a soil like here, okay? And this soil has a horizon that's very dark. So we have a dark color here. And we have a B horizon that's yellow. And here we have a C horizon that's gray. Why they have different colors? Well, dark colors, they represent high content of organic carbon or of organic matter. So we have this horizon influenced by high content of soil organic matter. This yellow color, they can represent goethite. That's a iron oxide that has water too inside the crystal. So we have no much content of iron, but we have water. Okay. We can have a lot of activity, biological activity. Okay. And this gray color, they represent a headset, a reduced iron layer, a depletion of iron. Why? Because maybe the tidal water is here. So here we don't have iron in an oxided formation, ferric horizon. It just has ferrous iron because we have water here. So we have different colors in different horizons depending on the pedogenesis, the process that occurs in each horizon. Okay? I hope that I answer your question, but I'm not sure. It's okay? Okay, please, Silvan, please tell me. Okay, Ken. Oh, Silverling, please, you can open your microphone.
Oh, sorry. Can you hear me now?
Yes, yes.
Okay. Yes, I was saying when you're talking about the goethite, you said there's water inside. And then when you described the gray color, you said in the gray color there's a reduction. There's a reduction of iron. So we don't
Yes.
have iron 3, but iron 2.
Yes, yes, yes.
So I'm asking if we also have water inside, or it's only in the reddish color where we have got water.
Oh, if we have water in a reddish color,
Yes. Did you say that?
oh.
I want to get it
Mhm.
clear if you said there is water in the reddish color.
Oh, okay, okay. If you have a reddish color, so probably you have a lot of hematite in the soil. And hematite, he is a mineral that's formed in soils that you don't have a lot of water. Like if you go to a desert, you can see a lot of red soils. If you go to a semi-arid area, you can see a lot of red soils. But sometimes you can find a red soil in an area that you have a lot of water. Like, okay, I can see a rainforest over a red soil. And you can ask why? Because this soil has a lot of iron. Okay, the soil color, it depends a lot of soil formation factors that doesn't depends only from the water. Water helps a lot to understand which color is the soil in, if you have a lot of water or if you don't have a lot of water, but you should comprehend a lot of several other factors that can influence the soil color. Okay, so you can find a red soil, a red horizon below a rainforest and a lot of water, but you should think, okay, if I have a lot of water and this soil is red, why? Okay, first of all, I can have a lot of iron in the soil, which is the parent material of the soil, or is banded iron formation, or is a sandstone, or is a shale. And these parent materials, they help to create, to form hematite. So I can find hematite even in a climate that we have a lot of water, okay? If the pH is high, because you has a soil that's formed from a shale or from a limestone, because they have a lot of calcium, a lot of carbonates. So you also forms hematite. So you can find a red horizon or head soil in a dry or wet area too. So you should think, okay? But if you have a flooded area, if you have a area site that's very, very influenced by water. If the tidal level it's high, so probably you just have gray colors because you just have iron in a ferrous form, like iron 2, okay? And if you have a yellow or red soil, you can have these materials. We can have too much water. You don't have so much water, but you don't have a red horizon in a flooded area. You don't have a yellow horizon in a flooded area. Okay?
Okay, thank you.
Okay. Welcome. Let me return here. Just a moment. Okay. Okay, we also should describe the color of the materials, the reductive morph fixtures. So I also use the Munsell color chart or any other equipment to describe the color of the bodies of the reductive morph fixtures. So let's see, I can just catch this material and compare this color with the on page of the Munsell color chart and say, okay, this is a color 10R6/8. Okay, this is the color of this coating, okay? This iron coating. Okay, it's not a problem. And if I found something like this, I should describe this color and also this color, the dominant color and the matrix color, the gray color, okay? So I should describe this and this color, and I take note, okay, this color is something like 7.5 yellow, red, let me just make a quick 4/6, something like that, okay? And this is 7.5 yellow, red, something like 8/6. So we have different colors here, okay? We also should describe the moisture state. It's quite easy because we just need to describe if the reducing morph feature is dry or moist. And it's quite important to describe it because if you have a dry reductive morph feature, maybe, just maybe, you don't have a tidal water, we don't have a flooding area. But if you have a moist reductive morph fixture, so you have a flooded area, we have a lot of influence from water, okay? And we should also describe the shape of the reductive morph feature. How is the form of this material? How can I describe this material? Okay, and we have a lot of shapes that can be described, like the cubic, the cylindrical, the dendritic, lenticular, pendular, plate, reticular, rosette-like, spherical, thread-like, and irregular. We have all these shapes, okay? Here we can see a cubic material. It's not a cubic iron or manganese nodule. It's a cubic crystal of halite, okay? But it's not, just to know that we have the same dimensions in a vertical and horizontal dimensions. So I can see this and put this crystal here, and they have the same dimensions here and here, okay? We can identify some cylindrical materials like this, like tubes of calcium carbonate, okay, to calcite here and here. We can see some spherical or iron nodules like here, oh, like here. It's not so perfect, but you can see here too. So spherical iron nodules here. They are very, very common. Here you can see some spherical iron masses, like here. Oh, it's quite beautiful. You can see some here. And we can find something like here. These fringes here and here. Okay. We can see a platy manganese nodule is in my hand, just this. Okay. You can see a horizon. Okay. We can see a lenticular gypsum nodule. It's this shape, this disc shape, circular shape, okay, of the material. You can see this dendritic that remembers a root. You can see a irregular, because you don't see a specific shape. It don't has a specific shape. It's not partner. You can see several nodules or concretions, and all of them has a specific size and specific shape. So you just say that's irregular, okay? Oh, in here we have a quiz to answer that I ask you all to answer to me, a very easy question. If this is a mass, or a nodule, or a concretion, okay? To answer this quiz, I ask you to access menti.com and use this code and answer me if you think that's a mass, a nodule, or a concretion. So please go to Menti, use this code, and answer me. Okay? I will answer too, so I can check if the link is working. Four, two, okay. Oh, I'm not sure it's working. Maybe something happened. Oh, so you can just put in our class, so we can identify if this is a mass, or nodule, or a concretion. Which one do you think? Please just put your answer here. I will share it again, okay? It's a mass, a nodule, or a concretion, this material in this picture. What do you think?
I think it's a concentration.
concentration? Why? Why do you think that's a
Because
concentration?
because it has got that cemented feature and it's visible.
Let me share again on
Unlike a
screen.
mess where we said a mess, it's not cemented, we can easily break.
Yes.
Yes.
So we
But
agree
it's
that
not a nodule as well, because we said a nodule has got layers. Did we mention layers in nodules? Yes.
which one has layers, nodules or concretions?
No dials.
Nodules, they are layers. Are you sure?
I'm not convinced.
I'm not sure. Okay.
They
Let's
will
see
help
here.
me.
Someone can help her? Here. Concretions, they has layers, and these nodules, they don't have layers. So we are watching
Okay.
this. Okay. So this, we don't see layers here. So there's a nodule. Okay. Everyone agree with me? That's quite easy to understand. That's why this is not a mess, because this seems cemented. It's not easy to break this, but it's not a concretion because you can't see layers here. You just can't see a uniform mass of iron. Okay? Everyone agree? I hope that everyone, if anyone doesn't understand this, just let me know, okay? Okay, so, and this, I'm not sure if Menti will works again. Oh, okay, this working. Please. What is this? This is a mass, it's a nodule, it's a concretion. Okay. Oh. So let's go. This is not a mass because seems that very hard to break it. So probably these are cemented, so it's not a mess, okay. And I can't see any kind of layers or a partner here, so it's just some voids, some voids here, and an iron material, so it's a concretion, okay, but which kind of concretion? Let's see. It's a concretion of iron and manganese. It's an nodule of iron manganese. It's a plintite. It's a jarosite. It's an ironstone. Which one is this material? Oh. Okay, this is a nodule because you can see partner. You can see, oh, sorry. You can see a partner here. You can see layers here, okay? So it's a nodule and the ironstone because you can see a lot of material cemented. Oh, I'm sorry, my computer is not working very well. Sorry. What happened? Sorry. The computer is getting crazy. A lot of crazy. Okay, it's working. And here we can't see we can see layers, so it's a nodule, okay, and it's a ironstone because we have a lot of material cemented, and we have this material that's rich in quartz, in iron, and let's see another ones. Okay. It's a ironstone or iron manganese or jarosite or plintite. Iron manganese, I hope that they has red and dark colors. So we are just red. It's not red and dark. So it's not an iron manganese nodule. A jarosite. Jarosite is yellow. So I cut it off. And plintite are materials that doesn't have a lot of quartz, and ironstone are materials that we have a lot of quartz. Okay, so both of them are iron-rich materials, but ironstone are cemented materials that we have a lot of quartz. So this, it's a platy iron stone nodule. This material here. Let's see here. It's a platy because it's a horizon distribution. Okay. It's an ironstone and it's a nodule. Okay. People, I thought that this point could be a very interesting place to stop in this class. We will continue to discuss about reducimorph features in our next class. I hope that I will create some techniques so we can interact better. But I truly hope that you are understanding or open your microphone and ask me questions, okay? Don't get muted all the time. I really need to know if you are understand me, and you can ask me anything. So if you don't understand something, just let me know, okay? I'm truly asking again to read the material that I send it for you all, so you can read the material and ask me some questions in the class so we can go forward, okay? It's okay for everyone? Anyone has any question? Any doubt? It's okay? Okay,
Yes.
much. Oh, Zoe, please.
Okay, thank you. I wanted to have some clarification on the issue that you have raised earlier, which is you said that in tropical areas, the color of the soil are most dominantly red and yellow. except those around the rivers. So can I have some explanation in this regard, please? Why they are?
Okay.
Okay.
Okay. These areas like marine terraces or fluvial terraces, they are exceptions because the minerals that you can find in these areas are different. Like you can find some ferrihydrite, and ferrihydrite, it's a mineral that it's gray. Oh, it's not gray, I'm sorry, it's green. So the color of soil gets green because this material, this mineral, and there you can find some green colors, okay? And in some areas in the South Pole, you can find some blue colors, blue soils, but generally you can't find them in tropical areas because we need specific materials like ash, volcanic ash, and a low weathering, incipient weathering that we just can find in areas that are very dry and are recent material at the same time, so we can find some minerals that are blue. So as in tropical areas, we can find in general deeply weathering of these materials, even if you can find some lava or you can find some recent parent material, they generally are getting well different. The weathering and the leaching are very deeply, and you can find these materials. And the weathering and leaching produces oxides, like iron oxides. So it's why you find a lot of red or yellow soils in tropical areas, because these colors are associated to oxides of iron, like hematite and goethite. Okay?
Okay, thank you.
Welcome. Any more questions? No? Okay, people. So I see you all in the Wednesday. Please read the material, and if you have some question, just let me know, okay? You can send me an email or you can ask me in the beginning of the next class. See you all, and I hope that you are well. See you. Bye-bye.
Bye-bye, JJ. Thank you.
Thank you.
Goodbye, JJ.